Here we're going to go over this example in the blue box of dividing complex numbers. And we're going to do that by getting rid of the imaginary number in the denominator by using conjugates. So let's take a look at the example above. 5 plus 2i and 5 minus 2i are called conjugates. Notice they both have a 5 and a 2i, but one is plus and one is minus. When I use the FOIL method to multiply these two binomials, notice on the right how the i's cancel out and you're ultimately left with a regular number 29. Press pause and take a look at that example. Now we're going to use that same process to get rid of the imaginary numbers in the denominator. So we need to look at that denominator, 1 minus 2i, and think, what can we multiply that by to make it just a regular number, to cancel out those imaginary numbers? So the conjugate of 1 minus 2i has a 1 and a 2i in it, but instead of minus, we're going to do plus. So if we want to multiply by that in the denominator, we need to multiply by that in the numerator as well. Because 1 minus 2i over 1 minus 2i is just like we're multiplying by 1. So now let's use the FOIL method to multiply our numerator and our denominator. And this is what I get. So again, I just used the FOIL method. I multiplied the first, the outside, the inside, and the last. After you've done that, now we want to simplify our numerator and our denominator. So we're going to combine our like terms. Notice that the 2i minus 2i cancels out. Now we need to look at this last term here. And keep in mind that I squared is negative 1. So in the numerator, we have negative 2 times negative 1 is positive 2. And in the denominator, we have negative 4 times negative 1 is positive 4. So now let's simplify this one more time and combine our like terms. And that's our answer. And I noticed that I have a 10, a 15, and a 5, that the 10 and 15 can both be divided by 5. So I'm going to simplify this a little bit more. Think of this as 10 over 5 plus 15i over 5. So let's simplify that. And our final answer is 2 plus 3i.